Are you able to see the screen? If you are able to write that, otherwise no need to write. I will share this video afterwards to you, just to listen now. Today we are going to see the topic matrices introduction. It is a very basic. Actually the matrices is coming from the word matter. Actually it is that French word. So that means it is that mother of the mathematics. Actually the matrices were found in that 400 or 200 BC itself, but it is evolution is started in 1800 only. Okay, so first we will see what is the definition for this matrices. Matrices. A matrix is a rectangular array or arrangement of entries or elements, arrangement of elements displayed in rows and columns. So I repeat that the matrix definition is that a matrix is a rectangular array arrangement in elements displayed in rows and columns, and then put it in the bracket. Put with in a square bracket. So what is this? It is the square bracket. Actually in general the entries of matrix is there na, the elements of matrix is there na, it may be the real number or the complex number. So how can we write that in case the matrix can be written in capital letter, capital letters A, B, C, D like that, and then the elements of the matrix may be constant or variables. Just wait. Somebody is want to enter into that class. But you have to come in time, otherwise. Okay, fine. So what is the general form of the matrix? As I told that the matrix is denoted by the capital letter A equal to, the matrix is written in that a square bracket, and inside that we can write that as Aij. What is the order of this matrix? M into n. Actually m into n is there, but we have to pronounce it as m by n. The matrix order is m by n, where m lies between that I lies between that, here I is there, that is the number of columns, the number of rows. We can eliminate it. 1 less than or equal to I, less than or equal to m, comma 1 less than or equal to j, less than or equal to n. So this we can be written as A equal to a square bracket A11, A12, A1n, A21, A22, A2n, AM1, AM2, AMN. Here we can write this as row 1, row 2. How many rows are there? M rows are there. Row M. So totally M rows are there. Similarly, we can write this as column 1, column 2, column n. So how many columns are there? N columns are there. So these are the some examples of the matrix. A equal to, in case if I write that 3 by 3 matrix, then we can write 2 0 minus 1, 1 4 5, then 9 minus 8, 5. Here the element 4 is there, na? This element 4 can be written as A22. That means A22 equal to 4. That means first letter can be written as row, second letter is denoted as column. That means the value of A, that is the element of second row, second column, that is 4. Okay. Not only this, we can write as some combination of, or we can write that these are the constant, na? Sometimes we may write that this as a variable. Sometimes we can write that 1 minus 2, 3, and then sin x. Inside some variable also we can write sin x, 2 x square, cos x, 1, 3. So like that we can write variables. So here that elements of the matrix contains that constant, the elements of the matrix contains that variables. Here are we can write, sometimes it may be written as a complex number 1 plus 2i, 1 plus 2i, 3i, 2 plus 4i, 6i. If I write like that, means there is the complex numbers. So elements are complex number. Sometimes it may be the rational number, irrational number, integers. Okay, so these are the combinations. So what is the order of the matrix? Now also few persons are coming inside that, want to try. Okay, fine. So what is the order here? How can we write the order? That means if a matrix A, has m rows, expand this, m rows and n columns, then the order or size, we can write as order or size of the matrix A is defined to be actually it is m cross n na, but you have to read as, pronounce it as m by n. Okay, next we will see that the types of the matrix. What are the types of the matrices? I repeat that the matrix is that a rectangular array or elements displayed in rows and columns put within a square bracket. That is the square matrix definition. Then the matrix is denoted by that the capital letters, and then the elements of the matrix may be that constant or variables, and then order of the matrix is m by n. Actually that m by n is there na, in case m is not n, that is called a rectangular matrix. Rectangular matrix. If the matrix has m rows and n columns, m rows and n columns, also m is not equal to n, then the matrix is called rectangular matrix. Next one matrix is the square matrix. The definition is that if the matrix has equal number of rows and columns, that is m equal to that is m equal to n, equal number of rows and columns, then the matrix is called square matrix. See, for example, if a equal to 2 0 minus 1 and 1 4 5, here 2 rows are there, 3 columns are there, whereas m is not equal to n, so this is called that rectangular matrix. At the same time, if a equal to 2 0 1 4, that means here number of rows and columns are equal, then so what is the order of this matrix for that first one? First we have to write that number of rows, 2 rows, then column. Order is 2 by 3. This order is 2 by 3. But here the order of the matrix is, actually it is the square matrix. Square matrix. What is order? Order is 2 into 2. But we have to write that square matrix of order 2. Simply we can write that. No need to write that every time 2 by 2. Simply if you write that square matrix of order 2, then we can understand this. It is the 2 number of rows are there, 2 number of columns are there. Okay, fine. Next one is row and column matrix. We can write the heading in the different pen. Row and column matrix. What is the row matrix? Row matrix is that if the matrix has only one row and n number of columns, then the matrix is called row matrix. For example, only one row should be there, that means A11, A12, A1n. So how many rows are there? Only one row is there. How many columns are there? N columns are there, n number of columns are there. This is called the row matrix. Next one is the column matrix. if the matrix have only one column and m number of rows, then the matrix is called column matrix. See here the column matrix, for example, we can write that the column matrix A equal to some A11, A21, A31, etc. AM1. See here, the first value is that row, na? M number of rows are there, and then one column is there. One column is there. So this matrix is known as that column matrix. Next matrix is that zero matrix. Zero matrix. A matrix A equal to Aij of order m by n is said to be a zero matrix, is said to be a zero matrix or null matrix. So what are the other names? Zero matrix or null matrix. Even one more name is there, void matrix, VOID, void matrix. So there are three names are there for the zero matrix: null matrix or void matrix, denoted by zero if all the entries of Aij equal to 0. Aij equal to 0 for all the values of m and n. See, for example, if I write that the zero matrix of order 2, zero matrix of order 2, then we can write that 0, 0. It is a zero matrix of order 2. Similarly, if you want to write the zero matrix of order 3, then you have to write the 3 by 3 matrix. See, it is a zero matrix, but non-zero matrix. Non-zero matrix means it is not the meaning of all the elements are non-zero. At least one element of is non-zero, the matrix is called the non-zero matrix. See, many of them will misunderstand that non-zero matrix means all the elements are non-zero. It is not the meaning. Here I am writing the definition. A matrix is said to be, a matrix is said to be a non-zero matrix if at least one of the elements, if at least one of the elements is non-zero. See, for example, if I write that A equal to 1 0 0 0, it is that non-zero matrix. Then I can write that non-zero column matrix. It is very, very important. We will see this definition in our unit 1, non-zero column matrix. Actually, today I uploaded one video. I don't know how many of them will go through this. In that video, I explained that non-zero column matrix. See, non-zero column matrix means, we know that what is a column matrix. The matrix has one column and m number of rows. That is that column matrix. Non-zero column matrix means, if X is a non-zero column matrix, of order m by 1, then X can be written as some x1, x2, xn is there. So n number of elements are there. Okay, x1, x2, xn is there. Then it is not necessary all the elements are non-zero. Then at least one element of the matrix is non-zero. For example, here I am writing x equal to 1 0 0. If I write like that, then it is the non-zero column matrix. If I write that 0 0 0 mean it is a zero matrix, but non-zero column matrix means, please keep it in mind, many of them have done the mistake in this point. Non-zero column matrix means at least one of the element is non-zero, all other elements may be that 0. Okay. Next definition is that diagonal matrix, unit matrix, triangular matrix. Diagonal matrix, unit matrix, triangular matrices. Diagonal elements means, first one, diagonal matrix. Diagonal matrix is if a square matrix, See, for the diagonal matrix, it should be that square matrix. It should not be that rectangular matrix. Okay. So I start with the square matrix. Already you know what is mean by square matrix. Square matrix has that equal number of rows and columns. Okay. So diagonal matrix means in a square matrix, a square matrix A equal to Aij of order n by n is called diagonal. It's called diagonal if Aij equal to 0 whenever I is not equal to j. See, I equal to j means diagonal elements. Here we can write that the diagonal element is diagonal matrix A equal to, here we can write A11. In case I is not equal to j, I is not equal to j means 1, 2. See, if Aij equal to 0, whenever I is not equal to j, when that I is not equal to j, except in the diagonal I is not equal to j. So here in the diagonal A, 2, 2, etc. A, n is there, remaining all the elements are 0. ANN. Okay, only diagonal elements are there, the remaining all the elements are 0, that is called that diagonal matrix. And now we extend this unit matrix. Actually the unit matrix is denoted by I. Unit matrix is denoted by I, capital I. I equal to, if all the diagonal elements are 1, the remaining elements are 0, then it is called that unit matrix. See, for example, unit matrix of order 2 is 1, 0, 0, 1. At the same time, the unit matrix of order 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. Here we can extend one more definition, scalar matrix. You can write as note, scalar matrix. Scalar matrix means in case all the diagonal elements are equal, then it is said to be that scalar matrix. That means if you are multiple with one scalar in that identity matrix, that is called the scalar matrix. So scalar matrix means, yeah, it is a diagonal matrix, whose entries along the principal diagonal principal diagonal are equal is called a scalar matrix. Is called a scalar matrix. For example, A equal to C 0 0 0 C 0 0 0 some constant value. If you multiply with that the constant C in the unit matrix, then we will get that the matrix like that, then it is known as the scalar matrix. So what are the definitions we have gone through? As I told that no need to write now, then you can write afterwards, because I will send these notes afterwards. I will share this videos also. Now we will see all the definitions one by one. First we have seen that what is meant by that matrix. Then what is meant by that row matrix, what is the order of the matrix, what is meant by rectangular matrix, square matrix, what is meant by that row and column matrix, and then what is meant by zero matrix, non-zero matrix, non-zero column matrix. This non-zero column matrix is important for our subject, and then this diagonal matrix also important. It is important, diagonal matrix. And then next we see that triangular matrix. There are two types of the triangular matrix. One is upper triangular matrix and lower triangular matrix. Triangular matrix. First heading is upper triangular matrix. See, it is in the word itself, the meaning is there. Upper triangular matrix means upper the diagonal is non-zero, and below the diagonal all the elements are zero. Below the diagonal, it is the diagonal, that CCC is there, na? That CCC below the diagonal, if all the elements are zero, then it is said to be that upper triangular matrix. That means upper that the diagonal, the elements are non-zero, and below all the elements are zero. See, I write the definition here. A square matrix. So here also we will look all the matrix are the square matrix. A square matrix is said to be upper triangular matrix if all the elements below the main diagonal or principal diagonal, because there are two diagonals are there. This is also the diagonal, this is also the diagonal, two diagonals are there, but this is the main diagonal. So main diagonal are zero. I repeat that a square matrix is said to be upper triangular matrix if all the elements are below the main diagonals are zero. That means, for example, we can write that 4 3 0 0 7 8 and then 0 0 2. Here okay, I said that it is all the elements are non-zero, na? It is it is not necessary all the elements are non-zero. It may be that 0, but compulsory below the diagonals are non-zero. So sorry, below the diagonals are 0. See here, it is that upper triangular matrix. So it is a diagonal. Below the diagonal, the elements are 0. It is known as that upper triangular matrix. Similarly, we can define that lower triangular matrix. Lower triangular matrix. Lower triangular matrix is a square matrix is said to be, it's quite opposite is that lower triangular matrix. See, in the upper triangular matrix, below that the diagonal all the elements are 0. For the lower triangular matrix, above the diagonal, above the main diagonal, these elements are 0, then it is said to be that lower triangular matrix. A square matrix is said to be lower triangular matrix if all the elements are above the main diagonal are 0. See, for example, A equal to 2 0 0 4 1 0 and then 2 1 1. Now see that the below diagonals may be that 0 or non-zero, but above the diagonals all the elements are 0. So in general, how can we write that the upper triangular matrix and lower triangular matrix? Okay. In general, we can write that the lower triangular matrix A equal to A11 0 0 etc 0, A21 A22 0 etc 0 and then etc AN1 AN2 etc ANN. So from the diagonal above all the elements are 0, then it is said to be that lower triangular matrix. Next one is algebraic operation on matrices. Algebraic operation on matrices. First one is multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar. See, for example, so in case A equal to Aij of order m by n is the given matrix. Is the given matrix. In case if I take that some scalar A, k is the scalar, k is the scalar. If I multiple with that k, the matrix will become that k into Aij. That means you have to multiple each and every element with k inside the matrix of order m by n. See, for example, if A equal to 1 0 0 1, if I want to find that 10A, then you have to multiple with the 10 each and every element of the matrix. Okay, it is the multiplication of a matrix by the scalar. Then addition and subtraction is the second one. Addition of two matrices first thing is, for addition of two matrices, if we consider two matrices, if A and B are the two matrices, the order should be same, with the same order. In case if they are in the different order, we are not able to add or subtract. First one is addition of two matrices is that first condition is that the same order. For example, if A is that of order 2 means B is also of order 2, then only we can add, otherwise we are not able to add this. In case A equal to, if A equal to Aij of order m by n, and the other matrix the B equal to Bij of order m by n, same order, are the two matrices, then the sum A plus B is that you will get some matrix Cij of order m by n, where Cij equal to Aij plus Bij. Cij equal to Aij plus Bij. That is, you have to add that the corresponding values. See, for example, A equal to 4 root 5 7 minus 1 0 0.5. is A and B equal to root 3 root 5 some 7.3 1 1 by 3 1 by 4. So for that, to find that A plus B, you can find that new matrix by adding the respective elements of two matrices. That means 4 plus root 3 root 5 plus root 5, we can write this as 2 root 5. Then 7 plus 7.3 is that 14.3. Then minus 1 plus 1 you will get, that is equal to 0. Then 0 plus 1 by 3 is that 1 by 3. Then 0.5 is 1 by 2. Then plus 1 by 4, that is equal to 3 by 4. So this is the final matrix you maybe get. Similarly, if you want to find that A minus B, that is subtraction of the same procedure, the two matrices has the same order, and then for subtraction, instead of plus we have to do that minus. That means 4 minus root 3, then root 5 minus root 5 is 0, then 7 minus 7.3 is minus 0.3, then minus 1 minus 1 minus 2 minus 1 by 3, then we will get here 1 by 2 minus 1 by 4 is 1 by 4. This is the operation on matrices. It is very simple. Addition is that very simple. Addition and subtraction is very simple. But that multiplication is the different. Multiplication of matrices. Even today one student is asking the doubt in that multiplication of matrices. First we can write the definition for this. First, what is mean by that? How can we confirm that the matrix may be that multiply or not? Okay. So first we write one definition. We need to confirm one rule is there for this. A matrix A is said to be conformable for multiplication with the matrix B if the number of columns of A is equal to the number of rows of B. Okay. So that means, what is the meaning of this? In case I draw here, if A and B are two matrices. See, A as that with the order m by n, and then B as the order n into some other column. Okay, so here we can see that for the product the number of columns of A and then number of rows of B should be equal. Must be same. That means here m by n is there, n into p is there. For example, I write that one more. So in case A is the matrix of order 2 by 3, B as that the matrix of order 3 by 2. See here, A as that number of columns is 3, B as that number of rows is, number of columns is 3, here number of rows are 3, both are equal, then only we can confirm that A and B may be that multiply. In case if it is 2 into 3, A is 2 by 3, and then here also 2 by 3 is there. We are not able to multiply these two matrices. See, number of columns are 3, but the number of rows are 2. We are not able to multiply. It is the correct one, it is the wrong one. So in case this condition is satisfied, then only we can multiply. The condition is not satisfied, we are not able to multiply these two matrices. Any doubt in this definition?
Excuse me, sir.
Yes.
Sir, your screen is not visible to us.
Yeah, it is visible only, I think. It is visible.
Yes, sir, it is visible.
It is visible only. I didn't do anything. You can check it that. Check it please. Any doubt is there in the point? Multiplication of matrices?
No, sir.
No, sir.
No, na? See, first matrix, for the first matrix, number of columns and the second matrix number of rows are equal, then you will get that the matrix, if you multiply these two, you will get that the resultant matrix of order m by p. Actually, you will get that the product matrix should be in the order, product is of order, what is the order of the matrix? M by p order. So this should be, you have to be keep it in mind. First thing is first row column, first matrix column number of columns, second matrix number of rows are equal, and then we can multiply these two matrices, and then the resultant matrix should be in the order of m by n. First matrix number of rows, second matrix number of columns is that product of the matrix of order. Okay, see for example, if A equal to, I write that A1, A2, AN, fine, it is order 1 by n, and then B equal to B1, B2, Bn, this order is n by 1. Then how can we find that AB? AB equal to A1, A2, an and then multiply with b1 b2 bn, that is equal to a1 b1 multiply with a1 b1 plus a2 b2 plus etc. an bn. You can see that the first matrix column, the second matrix row should be equal, then the product, what is that final result of this matrix? Matrix is that of order 1 by 1. First matrix number of rows, second matrix number of columns. Okay, so this is that matrix. That way you may be connected with this. For example, in case if A equal to, it is very important, this one is important, A11, A12, A1n, A21, A22, A2n, AN1, AN2, ANN. If x equal to x1, x2, xn, then what is AX? First you have to check whether it is multiply or not, then what is the order of this matrix. First check it whether it is multiply or not. What is the order of A? What is order of A? What is the order of A here?
3 by 3.
Not 3 by 3. Here I am right now. It is not 3 by 3. It is the order of square matrix of order n. It is not 3 by 3. I put that extra na.
Yes, okay, sir.
It is n by n. And then second one is row matrix or column matrix?
Column matrix.
Column matrix. How many rows are there?
3 rows.
No. Here also you
N rows.
n rows are there. How many
N rows
columns
are
are
there.
there?
Okay, sir.
How many columns are there?
1.
Only
1.
one column is there. Then is it possible to multiply now? How can you confirm these two matrices are multiply?
Yes, sir, it is possible.
It is possible. How?
The number
First
of
row,
columns of first and the
number of
rows of
columns is
second is
n.
same.
Second row number of
The
rows are n.
rows are
So
N.
n both
So
are
they can
equal.
be multiplied.
We can multiply. And then what is the resultant matrix? What is the order of resultant matrix? First matrix number of rows and then second matrix number of columns is that it is a resultant matrix. So how can we multiply? A11 x1 plus A12 x2 etc. A1n xn, A21 x1 A22 x2 A2n xn etc. an1 x1 an2 x2 etc. ann xn. So here we can find that Ax. See that Ax equal to, you can write the note. Actually from this only we are finding that characteristic equation. Today I have written that characteristic equation. You know what is a characteristic equation? Anybody? Mod A minus lambda I equal to 0. That is the characteristic equation. Is the characteristic equation. So from this only we are finding that a minus lambda I equal to 0. How? In case if we write that ax, we can write this as lambda x. Some value of lambda, in case some value of lambda into x. So that implies we can write that this is the note only. If you are not able to understand, I will explain once again. Ax minus lambda x equal to 0. Then we can take that x outside, a minus lambda, but here lambda is that scalar, but we have to write as a vector. So we have to multiple with that I, a minus lambda I. If you are taking x outside, that is equal to 0, but this x is the non-zero column vector. That's why I written before. You can see that video properly. Then x is the non-zero vector. X is not equal to 0. You know, in the multiplication rule of generally in mathematics, if a b equal to 0, either a equal to 0 or b equal to 0. Listen, either one of them equal to 0. If b is not 0, a is compulsory equal to 0. So here x is not equal to 0. The other thing, a minus lambda I equal to 0, since x is not equal to 0, because x is the non-zero column vector. So a minus lambda I equal to 0. This is the matrix. If you take the determinant of a minus lambda I for this equal to 0, is the characteristic equation. Okay, it is only the note. Actually, how this form that characteristic equation, what is the use of this characteristic equation, then how to find that the characteristic equation of 2 by 2 matrix and 3 by 3 matrix, already we have discussed in the class today. So this is that matrix multiplication rules. These are matrix multiplication rules. Then tomorrow we will see many problems in matrix multiplication and few more examples in basic definitions in the matrices. What are the other operations are there? Okay, any other things are there? Any other doubt is there from this class? Let me know. Quickly we can recap this class now. So today we have discussed what is the definition of the matrix, what is mean by the row matrix and column matrix, what is mean by the rectangular matrix and square matrix, and triangular matrix, unit matrix, zero matrix. All the things I have covered, I think maybe that in the introduction of the matrices. Tomorrow we will see what is mean by determinant, then how to find the determinant for 2 by 2 matrix and 3 by 3 matrix and other things. Then any other things are there? Did you go through the video today? I have sent many
Tomorrow in
videos to
class
you.
or 7 o'clock, sir?
What?
Tomorrow in class or 7 o'clock?
Tomorrow?
Tomorrow we will discuss about determinant in the class or 7 o'clock,
Not
sir?
in the class, not in the class. I will not discuss in the class because
Okay.
in the class there is no time. Within this week I will try to cover some basic things, then we will discuss afterwards. Thank you so much. If any other
Share this
things are
PDF,
there,
sir. Share.
yes,
Share this PDF, sir, in group.
yeah. I will
Thank you.
share this video and this notes also in that GC. Yeah,
Thank you, sir.
please you can go through this once again. Okay, thank you for joining.
Thank
Thank you for your interest.
Thank you.
And then
Thank you, sir.
daily you may be having the class, additional class.
Thank you, sir.
If you are
Thank
really
you, sir.
interested, if you will join, yeah, any other things are there? Somebody is asking something, yeah. If there is no doubt, you can leave that class now.